I'm Pete Usher. I'm an apprentice engineering technician at Siemens Industrial Turbo Machinery in Lincoln, and this is how to make it in industry. At Siemens, we're part of a multinational company. We employ approximately 360,000 people in over 120 countries worldwide. We use the basic design of jet engines that have been developed to make gas turbines. These are used in industry to generate electricity, pump gas, pump oil, and provide power where it's needed. They're all over the globe, places like Saudi Arabia, America, the UK, and recently they've been used in the aid efforts in Japan after the tsunami. The most important part of a gas turbine is its blades. These blades come to Siemens as a cast block. We can't use this. We grind a root block on a CNC grinding machine. Again, we can't use this. Once the root block's been ground, we grind an airfoil onto the blades, and then this will in turn fit into a disc, giving us the power. This machine is a CMM, which stands for a coordinate measurement machine. This machine costs £140,000. What happens is there's a probe on here. The probe touches onto the parts, and it measures from a CAD model where it should be. This then tells us how big the part actually is. This machine is called the sheath. This is where we bring all of our centre casings. What the centre casings are is the main part of the turbine, the big body. These parts holding all the power, the gas, the air, and all of the rotating parts. Without these, there will be no gas turbine. If there's a slight leak in any of these parts, then we'll lose power, performance, and potentially the engine could vibrate itself to pieces. So it's important we get them right. Where's your clocking plant? This one? Second. Go. From the moment you start at Siemens here in Lincoln, you kind of learn about the gas turbines. There's a general brief about how it works. You get taken on a tour around the factory, and as you're up at college and you come back to work, you go around the different sections, and it's a good way just to kind of like, I suppose, learn about all the different parts, how they fit together. This is the compressor rotor, as we've seen earlier. The air flows through the compressor, up into an igniter, and then it ignites and pushes the air through these blades here. This again turns this, and this machine here is where we check the balance. If the rotor's not balanced, then it could vibrate, and then if it starts vibrating, it's going to fly out of an engine. Everybody's really sound. You come in, you all have a laugh. It's, oh, can't I buy you a drink even though they're free, and joking around like that really. This is the assembly area. This is where the rotor meets all the casings and parts that we looked at earlier. What we need to do now to get a fully working gas turbine is assemble the other halves of the casings, attach all the burners and igniters which go on these points here. We need to then put the pipework on, the electronics, and then test it. I'd recommend coming here and doing an apprenticeship because you've always got the opportunities to do what you like as long as you put the time in and show you're dedicated, and you get to play with some giant machines and make a difference in the world. And then of course there's the money. So that's always a good side of things. This is the final part of the engine build. All the pipe work's gone on, the electrics and the burners here. This is ready for testing now, and fingers crossed it'll pass test and go out to the field. Siemens have offered me this opportunity to progress further than I could have imagined in the engineering side, and it's not going to stop me now. I'm going to keep going. This is Siemens, and this is how we make it in industry.